I'll be going over the umpire process for check if the number is a sum of powers of 3. So for our understand step, so we're given an integer n, and then we want to return a boolean, true or false, depending if we can represent n as a sum of distinct powers of 3. If we can represent n as the sum of distinct powers of 3. I guess our boolean is answering that question, so can we represent n as the sum of distinct powers of 3? So for some examples, right, if we're given n equals 12, we want to return true, because right here, right, it says, so 3 to the power 1 plus 3 to power of 2 are distinct powers of 3, and we can use that to add up to 12. Then we have n equals 91. We want to return true because 3 to the 0 plus 3 squared plus 3 to the 4th, that equals 91. And then for n equals 21, we want to return false. So off the top of my head, I'm just thinking, so we'd have, so we could have the largest power being 3 to the third. That'd be, no, I can't do 3 to the third because that'd be 27. That'd be 9 times 3, 27. So our largest power would be 3 to the squared, so we'd have 9. And then we'd have 3 to the 1, the first. So that'd be 3, so that'd be 12. Yeah, we'd probably have to repeat something, so we'd probably have like 3 to the squared twice, and then that'd be 9 plus 9 equals 18, and then 3 to the first is 3, so it'd be 18 plus 3 equals 21, so that'd probably be the way we have to represent it. And then so we have to repeat, so this problem's asking for distinct powers of 3, so that wouldn't work. So in terms of matching, I think I have seen problems before where you use a loop and then you like check its remainder to see if it fits constraints. So that's what we do here. Like I don't think it was powers of 3, but it was probably another powers problem. Like we had to see if like every iteration of the number is like divisible by a certain power. And then so understand match plan. So the plan, so just use a while loop that goes while n is greater than 1, because if we reach 1, we should have a sum of a number that has a sum of distinct powers of 3. So we use a while loop that goes while n is greater than 1, and then we check if the remainder of n divided by 3 is equal to 2. Then I believe we do this because it means we'd have to like repeat a powers of 3 to be able to get the sum of this number. So if we get 2, it means we'd have to like do some sort of repeat. it means we wouldn't have like distinct powers of 3 for the sum of this number. And so if it is 2, then we return false. Then we just use integer division to divide n by 3. Then if we get to the end of the loop, then we just want to return true. Alright, so understand match plan implement. So we have while n is greater than 1. So if we reach 1, it should be a powers of 3, and that means yeah, we return true. And so if n %3 is equal to 2, right? That means we need like multiple powers of 3 to get the sum of this number. Then we just return false. Otherwise, we just do integer division, so n divided by equals 3. So we just do n divided by 3, like integer division. Then if we reach the end of the while loop, so that must mean n is 1, then we return true. So I run it. Yeah, looks like we got all 3 test cases. Submit. Yeah, so we're able to get it. Yeah, nice. And so in terms of evaluate, I think for time, I believe it's O log 3n, because our while loop is based off n and how many times it takes to get to 1 by dividing it by 3. And then for our space, I think this solution uses pretty good space, just O1. We don't create any new variables. We just have this check, and then we're just using n the whole time, so it uses good space. So thank you. That's my solution for check if number is a sum of powers of 3.